Hello, Math Wizards. Welcome to a new lesson episode of Just Math PH. So, for today's lesson, we will be learning about solutions to quadratic equations. The specific objective for this lesson is you will be learning about solving quadratic equations by extracting square roots. Now, the three important questions in this lesson: what is a solution? Second, is it possible to have more than one solution? And third, what is extracting square roots and when to apply this method? So as a review, a solution is any value that satisfies an equation. Again, ito ay isang value that satisfies an equation. So we know that an equation must have an equal sign. So ito class, x plus 2 equals 5 is an equation. So it satisfies, ipapakita ko later how thus a solution satisfies an equation. Now, here in this equation, x plus 2 equals 5 has a variable x. Na yung x natin or ang variable natin, we know that it represents an unknown number. So, ano ba yung number na pag i-add natin ng 2, the result would be 5. So, simple. Yung x natin is equivalent to 3. Okay, anong ginawa natin dito? We replace x with 3 or we call it substitution. We substituted 3 to x. Now let's copy. Plus 2, the result is 5. So alam natin 3 plus 2 equals 5. So 3 plus 2, that is 5, equals 5. Hindi ba totoo? 5 equals 5 is true. Ito yung tinatawag natin na satisfies the equation. Ibig sabihin, if yung last part ng computation natin is yung left side ng equation will be the same with the right side of the equation, it means yung value ng solution natin, which is 3, satisfies our equation. So we call 3 again to be our solution. Now, so let's write here, yung solution natin is equivalent to 3. So, isa lang yung solution natin for this equation. By the way, there is another term for the word solution. Ito yung tinatawag natin na root. Solution or root are the same thing. Ibig sabihin, we can also call 3 as the root or our root. Now, we have here the quadratic equation x squared minus 4 equals 0. As a review, this equation is called quadratic equation because the highest exponent of our variable x is 2. Now, let's go back to the first example, the first equation we had earlier, which is x plus 2 equals 5. Now, notice the variable x has an invisible exponent of 1. Right? Its exponent for x is 1. Now, since the highest exponent of the variable x here is 1, this equation is what we call the linear equation. And it has one solution, which is 3. Now, this equation, the quadratic equation x minus 4 equals 0, let's see how many solutions can we get out of this equation? So what do you think would be the value of x, which is raised to 2, and then we will subtract it by 4, the result would be 0. So what do you think would be the value of x? Now, let's try x is equal to positive 2. So what we'll do, we will substitute 2 here to x. So that becomes 2 squared minus 4. Will that be equal to 0? So simplifying 2 squared, we know that 2 squared, that is 2 times 2. And that is equivalent to 4. Right? Meaning you have to write dalawang base na 2, and then you have to multiply them, so that is 4, and then we copy minus 4 equals 0. Now 4 minus 4 is equal to 0, so 0 is equal to 0, which is true. So here, the last part shows that it satisfies our equation. It means that x equals 2 satisfies the equation x squared minus 4 equals 0. Then we can call 2 to be a solution. Or the term root. Now, do you think there is another solution or root for x squared minus 4 equals 0? So let's try the value of x equals negative 2. So let's try if negative 2 can be a solution to x squared minus 4 equals 0. So we will substitute negative 2 to our x here. So that becomes negative 2 raised to a power of 2. Copy minus 4 equals 0. Now, negative 2 raised to a power 2, it means we have to write dalawang negative 2 and then we multiply them. So negative 2 times negative 2 is still equal to positive 4. So 4 here, since that is 4, copy minus 4 here. Okay. The result is equal to 0, right? Since 4 minus 4 is equal to 0, so we can write that as 0, and then equal to 0, which is true. So since the last part is true, meaning negative 2 here, or the value of negative 2 satisfies our equation x squared minus 4 equals 0. So since it satisfies, negative 2 is also a solution. Or root. Kung mapapansin ninyo class, we have two solutions or roots. ito yung -2 at saka yung +2. Right? Now, obviously, this tells us that a quadratic equation will have at most two roots. Right? Now, what does the exponent of our quadratic equations tells us? It means that since the highest exponent of our variable x here is 2, it somehow signifies or implies that our equation will have at most two roots. Okay, I will explain later why it is at most two roots. So obviously, our example here has two roots. So ibig sabihin, kung say at most, pwede isa lang yung solution, pwede dalawa yung solutions, at pwede rin wala siyang real solutions. Now, how about this quadratic equation? The quantity of x plus 1 quantity raised to the power 2 equals 0. So this quadratic equation is not in standard form, but we know that this is a quadratic equation because if we expand x plus 1 squared, that would be x squared plus 2x plus 1 equals 0. So this form, though it's not in the standard form, but this equation is still a quadratic equation. But I want to use this example since it is more easier for us to find the solution by substitution method. So let's erase first this part. Okay. So what do you think would be the solution for this equation? Now, or what is the value of x here? So let's say x is equivalent to -1. Now, if x is -1, we will substitute it to x here. So that is -1 plus 1. Okay, then raised to a power of 2 equals 0. Now, -1 plus 1, that is obviously 0. And 0 squared equals 0. So, obviously, 0 squared is 0. So, that is 0 equals 0 is true. Now, since the last part of our computation is true, it means that x equals -1 satisfies our quadratic equation. And means that x equals -1 is a solution or a root. Now, can you think of any possible solution other than -1 for this quadratic equation? Now, if we will replace x with 1, let's say that is 1. 1 plus 1 is 2. And if we raise it to a power of 2, 2 squared is 4, and it's not equal to 0. So I can think of any other value for x except -1. Thus, this equation is an example of a quadratic equation which has only one solution, right? It has one solution. Okay, going back to our first example earlier, this equation has two solutions, the +2 and the -2. So we will write it here. It has two solutions. Now, let's have an example of a quadratic equation which has no real solution. Okay, x squared plus 4 equals 0. Okay, x squared plus 4 equals 0. Now, can you think of any value for x here in which you raise it to a power of 2 and then you add it by 4? The result will be 0. Can you think? Is there any value for x here? Now let's say we try -2. Okay, let's try -2. Now -2 squared is equivalent to +4. Right? 4. That's 4. And then 4 plus 4 equals 0. Is that true? 4 plus 4 is 8. And obviously, that is not equivalent to 0. So there is no such value for x here. That when we add it by 4, the result is 0. Right? So it's not possible. So we have to erase this part. It's not possible. Now, it implies, or it just tells us that this equation here, x squared plus 4 equals 0, x squared plus 4 has no real solution. Okay, let's go back. This equation here, x squared plus 4 equals 0, is a quadratic equation, but it has no real solution. This quadratic equation here, x plus 1 raised to a power of 2 equals 0, has one solution, which is -1. And this equation here, x squared minus 4 equals 0, has two solutions. So that's what I meant by the quadratic equation to have at most two roots or solution. Pwede dalawang solutions, pwede isang solutions, pwede rin walang real solution. Kagaya na nangyari kanina in this example. Extracting square roots. Now, extracting square roots uses the symbol, this one. We call it the radical symbol. And also, the square root of any positive number has two square roots. For example, square root of, let's say 4. Now, square root of 4 is equivalent to positive 2 and negative 2. Why? Let's put it this way. If you want to find the square root of 4, meaning you want to know a number where if you square that number, the result would be 4. And the numbers that we can find are positive 2 and negative 2. Since positive 2, if we square it, it's equivalent to 4, right? And if we square negative 2, it's still equivalent to 4. That is why the square root of 4 is equivalent to positive 2 and negative 2. Let's have another example. How about the square root of 9? Square root of 9 is equivalent to positive 3 and negative 3 because squaring positive 3 and squaring negative 3 will both result to positive 9. Now, if you notice the pattern, the square root of any positive real number comes into two, the positive square root and the negative square root. For example, what is the square root of 49? Okay, what is the square root of 49? So we know that the square root of 49 comes into two values, the positive square root and the negative square root. Okay, now we know that 49 is equivalent to 7 squared. 49 is 7 squared, or 7 times 7, that is 7 squared. So we can replace 49 here with 7 squared. Now imagine that there is an invisible 2 on this corner. Okay, that's why we read this symbol as square root of 2, since there is an invisible 2 on this corner. We call it this index 2. Now, since the index 2 outside and the exponent inside are the same, we can remove the squared symbol or the radical symbol and together with the exponent inside. So let's remove this and this. Therefore, we are left with positive and negative 7. Thus, the square root of 49 is equivalent to positive 7 and negative 7. Okay, another example. What is the square root of 64? Okay, so square root of 64 is equivalent to positive and negative square root of, so 64 is 8 squared. So we can replace this with 8 squared since 8 squared is 64, and we know that there is an invisible index 2 on this corner. We can remove the radical symbol or the squared symbol and the exponent inside 2 since they are the same. So we are left with positive and negative 8. Thus, the square root of 64 is equivalent to positive 8 and negative 8. We have here a summary of some of the square roots of numbers, like square root of 0 is 0. So we cannot write positive and negative 0 because 0 is non-positive and non-negative number. So it's just 0, no sign. And square root of 1 is positive and negative 1. Square root of 4 is positive and negative 2. Square root of 9 is positive and negative 3, which we already solved it earlier. And we have square root of 16, which is positive and negative 4. Also, we have square root of 25, which is positive and negative 5, so and so on. So 0, 1, 4, 9, 16, and so on are examples of perfect numbers. Okay, since we know that 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, meaning these are the product of multiplying two the same numbers. So that's why we call the result or the product to be the perfect numbers. However, how do we find the square root of non-perfect numbers? Example, square root of 12. Now, 12 here is a non-perfect number, right? So how should we find the square root of 12? So first, we need to find two factors for 12 in which the first factor should be a perfect number and the other one is not. So for example, 12 is 4 times 3. We know that 4 is 2 squared. So 4 is a perfect number. Now we will replace square root of 12 by 4 times 3. Then we will replace the perfect number with 2 squared. By the way, do not forget the positive and negative sign outside the square root. So positive and negative, square root of 2 squared times 3. Now we can extract 2 squared, meaning we can transfer it to the other side or outside, but the result should be the square root of it. So we know that the square root of 4 or 2 squared, if it goes outside, it becomes positive and negative 2. So since the square root of 4 is positive and negative 2. The square root of 4 here is positive and negative 2. Now we are left with 3 inside. So you have to copy the square root symbol and then write 3 inside. Therefore, the square root of 12 is equivalent to positive and negative 2 square root of 3. Another example, square root of 32. Now 32 is not a perfect number. So again, we have to factor it in such a way that the first number should be perfect. Then we pair it with a non-perfect number. So we have two choices. We have 4 times 8, where 4 is perfect, and 16 times 2, which we have here 16 as the perfect. But which of the two choices we have to choose? Okay, so always remember to choose the factors which has the highest perfect number. So in this case, we will choose 16 times 2. So square root of 32 is equivalent to positive and negative square root of 16 times 2. Now, we will write 16 in an exponent form. So that is positive and negative square root of 4 squared times 2. Then we will extract 4 squared outside. So extracting 4 squared, that becomes positive and negative 4. So lumabas na siya. And the square root of 16 here is positive and negative 4. So we are left with square root of 2. Therefore, square root of 32 is equivalent to positive and negative 4 square root of 2. Since we know already how to extract square roots, we will be applying what we learned on finding solutions to quadratic equations using extracting square roots. Now, extracting square roots is very applicable to quadratic equations of the form x squared plus c equals 0, meaning we do not have the linear term. We only have the quadratic term and the constant term. So extracting square roots in finding the solution for these quadratic equations will really help us do the computation. So example, okay, find the solution or solve. When we say solve, meaning you have to find the solutions for this quadratic equation. Solve x squared minus 36 equals 0. Okay, so this is our first example. Now, to solve this quadratic equation, so observe that it has no linear term. So we can find the solution for this quadratic equation easily by using the by using the extracting square roots. So first thing to do is we need to make it that the left side of our equation, so this is the left side and this is the right side of our equation, we have to transfer negative 36 to the other side so that only the quadratic term is on the left side of our equation. So transfer negative 36 to the other side. So remember that if we transfer it, the sign of negative 36 must change. So it becomes x squared equals, so 0. We will not write anymore 0, but we will transfer negative 36 so it becomes positive 36. So again, what we did, we just transfer negative 36 to the other side. and then it becomes positive 36 now. And then notice that our the left side of our equation is of exponent 2, and 36 is a perfect number. What we will do extracting square roots. So we will apply square root on the left side of our equation. Since you write square root here, do not forget to write also square root on the other side. So we will do extracting square root. So remember that a square root must have positive and negative value. Now, square root of x squared, remember that there is an invisible 2 here. We can cross that out. So you have here x equals positive and negative square root of 6 squared. Since 36 is 6 times 6, or that is 6 squared. So replace 36 with 6 squared. We know that there is an invisible 2 here. We could remove that and the exponent inside. So we are left with x is equal to positive and negative 6. Meaning the roots of our quadratic equation, okay, the roots are, or the solutions, the roots or the solutions are positive 6 and negative 6. So for the second example, find the roots for the quadratic equation m squared equals 0, or solve the quadratic equation m squared equals 0. So since the left side of our equation is already the quadratic term, and on the right side we have here 0, we could directly go to extracting square roots. So we write square root symbol on the left side and do the same thing on the right side. So remember that there is an invisible 2 here, so we could cross that out. What is left is m equals, okay, we will not write any more positive and negative here since the number inside the square is 0, and 0 is non-positive or non-negative number. So square root of 0 is just 0. So that's our root. Okay, so the root or solution is 0. Okay, now let's move to the third example. Okay, so for the third example, we have here the square of the binomial x minus 3 minus 81 equals 0. So you may think that this is complicated, but actually it's very easy. Now, since this term here, x minus 3, is a term that has an exponent 2, we want x minus 3 to be isolated, or it should be left on the left side alone. So what we have to do, we have to transfer negative 81 to the other side. Okay, to the other side. So doing that, we will have, okay, we will have x, okay, x, oh no, okay, x minus 3 raised to a power of 2, then transfer negative 81 to the other side, so that becomes positive 81. And then we will now apply extracting square root. So just do the same thing. So write square root here on the left side and do the same thing on the right side. So do not forget the plus and minus. So we know that there is an invisible 2 here, so we can remove that one and the exponent to inside. So what is left is x minus 3 is equivalent to positive and negative. So 81 is 9 squared. So square root of 9 squared. So positive negative square root of 9 squared. So we know that that is equivalent to x minus 3 equals plus and minus 9. Last part of our solution, x minus 3 equals positive and negative 9, can be separated into two equations. So to do that, we have to separate them with a vertical line. So on this side, we will write x minus 3 equals positive 9, while under the other side, x minus 3 equals negative 9. So what we will do, we will solve for the value of x here and at the same time here. So we have to transfer negative 3 to the right side of our equation, so it becomes x equals 9 or positive 9, then transfer negative 3, that becomes positive 3. So x here is equal to 12. While on the other side, we have to solve x here. So we have to transfer negative 3. It becomes x equals negative 9. Since this is negative 3, transferring into the other side, that becomes positive 3. So x is equivalent to negative 6. Now we have here the two values for our roots. Okay, the first root is positive 12 and the other root is negative 6. Okay, so thus the roots for the quadratic equation are positive 12 and negative 6.